I have some really good news for you. You are now equipped to understand the physics of rainbows. Yes, you are. And the reason why is because it's involving refraction, total internal reflection, and dispersion, which you now understand as well. So yay! And we get a sequence of colors as in the little cartoon here. So to understand this, consider a water droplet in the sky. Here's the sun, a sunbeam coming in that has all the colors mixed in. So there's a ray of sunlight. It's got the red, the orange, the yellow, the green, the blue, the whole spectrum. They're all there, all the frequencies in the visible spectrum. I'm going to trace a red ray through. It gets refracted, and then it has total internal reflection over here, and then it hits this part of the droplet, and it actually comes out and refracts once again. Now, if your eyeball happens to be right here, aren't you pretty impressed with the way I made the eyelashes on this little drawing? I thought so. So the red part of that sun ray that has all the colors is entering your eye. But let's now trace a violet ray. Oh, by the way, if the light is coming into your eye, you see it. Anything you see, the photons coming in this way, you see it projected back from that direction. So you see it. Man, I can't draw that. I can't trace this thing. Straight back from where it's coming into your eye is where you see it. So, just because an object is over here, if the ray bounces around, doesn't mean you see it over there. You see it in the opposite direction of the direction it comes into your eyes. You see it back here. All right. Now, violet refracts more, but there's total internal reflection. And in this particular bounce, it comes out, refracting again, and you can see that because it's not entering your eyeball. And of course, all the other colors between red and violet are here, so you don't see them either. So you're seeing the red, and that's it. It's the highest raindrop where you can see the red. Now let's consider another raindrop here. And I've got the same kind of sunbeam coming in, and it does the same thing with the red, just replicated here. And notice you can't see the red. But now let's trace the violet. So here's the violet. Oh! And it hits your eyeball as well. Well, this raindrop is just right to see the red light projecting back like this. This raindrop is just right to see the violet light projected back like this. And in between this location and this location would be raindrops that are just right to see all the other colors, as indicated here. Red, orange, yellow, green, blue, violet. So, the droplets in different elevations enable us to see the various colors. So you never see a rainbow apart from the existence of the sun, okay, and the existence of water droplets. Water droplets have to be in front of you, and the sun has to be in back of you. Isn't that something? So the higher droplets bring red to our eyes, the lower droplets bring violet, and everything else in between. Now, where does the sun, the rain, and you have to be? Well, I mentioned the sun is in back of you, the droplets are in front. But there's a certain relationship here. Okay, so if you look at this angle here, considering the direction from the sun to the droplet to the red ray to your eyeball is 42 degrees. So that's 42 degrees. The sun to the droplet to you. And if we consider the violet, the angle from the sun to the droplet to you for the higher frequency, shorter wavelength, is 40 degrees. So it ranges from 42 degrees to 40 degrees, which means the rainbow is about 2 degrees in width. Isn't that amazing? So there it is. I just explained how a rainbow is formed. Haven't explained the double rainbow. Maybe we'll get into that too. But let me show you a wonderful image of a rainbow. You can see the whole thing. Notice the proper color sequence. And you will notice the double rainbow doesn't quite go all the way across the sky. That would just be too much, too much. We wouldn't know what to do with that. We wouldn't know what it means. So we won't look at that. But isn't that pretty? And actually, it's darker in between the main rainbow and the double rainbow. The way the phases of the light add or subtract, basically there's cancellation. It's actually darker in here, and you'll notice it's lighter on the inside of this one. So that might be worthy of more significant analysis, but not right now. Graphic, actually one more photograph here. This is really amazing. What's the shape of a rainbow? You might have thought it's a parabola because you see little parts of it. You might see that much and above, but if you look at it from an aerial perspective, you find out that really the shape of a rainbow is a circle. And this one is the main rainbow, and the secondary rainbow is around there as well. It doesn't just go all the way across the sky. It goes all the way around and meets on itself again. So that's really, really too much. Too much to even begin to comprehend. But you can try. And that is a really interesting picture. Not often obtained so well. So I wanted to show you that. So the physics of rainbows. May you be impressed for the rest of your days.